if we want to calculate the volume of a football, does that look about like a football to you? Yeah, whatever, the ellipse. Okay, so I'm gonna put the axis in the middle. Like so. That didn't work too well. Okay, how about that? So equation of this thing is given right here. Okay, now then we have to rotate this thing, so I'm gonna draw the rectangle. Let's say about there. My rectangles are usually red, and then of course use green to rotate this thingy. So we're going to have this kind of shape. How are we doing in sketching these things? Are you getting somewhat artistic? Can you draw these things? Okay, so it's the same thing as before. This side is y, and this is dx, isn't it? So my dv is equal to y squared dx, right? Oh, pi. I forgot pi. Pi y squared dx, eh? Pi r squared h. Okay, but what is my y squared? Well, we have to get it from here. Would that be too much algebra if I just write it down? Would that be pi and b squared and 1 minus x squared over a squared? Too much algebra? You want me to show you how that is done? Or can you do it? 1 minus x squared over a squared and multiply b squared, eh? Okay, well then my volume can be now from 0 to, do you see this and this a and this is b, right? So 0 to a and we double it. Good? Say yes. And pi b squared then 1 minus x squared over a squared and then dx. So we integrate, taking all of the constants out, and this becomes x and this becomes x cubed, therefore 1/3, so I'll just stick 3 here. Good. Say yes. So 2 pi b squared, and then this becomes a minus this becomes a cubed over a squared, so this is a over 3a. So that's 2/3 of an a, eh? So we get 4 pi over 3, and we have a b squared. Is that an obvious answer or is it a surprising answer? If you think about it, if a and b are the same, then this thing becomes a sphere, correct? So if a and b are the same, both become r, then it's 4/3 pi r squared. So same as before. You know what I'm saying? But if you're rotating it this direction, so b gets squared and a is not squared. Do you see if I rotate it about the y-axis, then it creates not a football but Advil looking, M&M looking shape? Do you see the fundamentally different shape? And that's bigger volume than this football? You want me to put it on 3D grapher? Yeah, let's do that. Hopefully we'll have enough time. So what we're looking at is this. Our current shape is x squared over, let's say, 4. plus y squared plus z squared this is what we just created. You know what I'm saying? Green? Oh, you know what I'm saying? That is rotating about the x-axis. But had we rotated this about the y-axis, then what we will create would be this. M&M. You know what I'm saying? So you see this is much bigger volume than before, than this thingy. You see? It's skinnier. You know what I'm saying? For that reason, see here, A is longer than B. So if we square B, that's smaller than if we square A. Because symmetry tells you that if we rotate it about the y-axis, then it would be A squared times B. That makes perfect sense to you now? The direction of the rotation or revolution matters a lot in this business. They don't give you the same shape, therefore they are not going to give you the same volume. So don't be assuming things like that. Okay, this is spatial geometry. You always have to think about the shape that you're creating. You got that? Okay, then I have this. Let's just think about this and don't write this down because it ain't gonna work. It's gonna blow up. But I want you to learn from my mistake here, okay? In order to save the resource, I'm gonna turn this thing off. Suppose we draw the rectangle this way. Because it says we have to rotate it, revolve it about this line, so it's like that. So we have to draw it sideways, correct? And then, so let me draw these things. So you're going to have inner thingy. You're going to have something that looks like this, eh? Don't draw this, it's not going to work. But you create something that looks like this. You know what I'm saying? Okay, let's take a look at what it is that we are doing here. Okay, we'll have outer radius. This is what I call big R, right? And then we'll have inner radius, correct? So what we have to do here is this dV will be pi. This is dy, right? But what is outer radius? We have to have some kind of function here, x1 and x2, don't we? But you look at this. I mean, we have enough algebra skill to find the inverse functions of this, but do you really want to do such a thing? We could if we really want to, but we don't want to now, do we? So we have to have so much better way to do it than do it this way, which is called the washer technique. Okay, okay. Not coming this way, hopefully it will be okay. Okay, so we scrap this idea. This is not going to work, okay? So let me get rid of all of this. So instead, we have to have a fundamentally new way of doing this. For that, I have animation. So yesterday, as opposed to the washer, I showed you this, right? Let me quickly recap the fundamentally different shape, right? Washer versus a shell. Good. So we need to do this shape. This is what we call shell or cylindrical shell. This is cylinder, infinitely thin. That says infinitely thin pineapple slice. Good. So let's see. This is our function. It's not exactly our function, but you get the shape. Okay. So we are revolving this colored region about this line, and let's see. So this is what we're creating. It's like, I think they call this thing bundt cake, right? They sell it at grocery stores. Yeah, what's the volume of this bundt cake? So in order to do that, the idea is we still draw that rectangle vertically, which is now parallel to this axis. When we are doing washer technique, we were drawing that rectangle perpendicular to our rotational axis, right? Now we are drawing it parallel, and then we're going to revolve it. These things really never get old. So we create this cylinder, and we're going to add them up. So if we create all of these things, it's going to look like that. You know what I'm saying? I know, amazing, isn't it? I really amaze myself sometimes. And in a classroom, I actually have a model, that shape model, that you can actually take out many different cylinders. But now you have to use your imagination a lot, okay? Okay, then we'll come back here. So we're going to do exactly that. So let me draw a rectangle. Let's draw it about here. Yeah, that looks good. Like that. Now I'm going to revolve this thing. So let's see if I can. That looks about right. That one, that's the inner radius, and then I'll have outer radius, which I will have start here. Huh, beauty. Okay, this is amazing. So we create something like this, okay? And I'm gonna have to freehand the rest of them. You know what I'm saying? Okay, that is the shape that I have to create. Now, how the hell do we find the volume of this thing? So let's get this thing right. This side is y, and this is dx. Then what? We're still kind of getting lost here, right? Okay, this line is y is equal to -1/2. So at least that tells you this much is 1/2, right? That distance is 1/2. How much is, I'm going to put that dx on top. How much is this distance? Can somebody tell me how long that is? That happens to be x. What? Why is that x? Because remember, when we say coordinate xy on this curve, that means x, y. You get it? I mean, sometimes like you've been doing it so long, you forgot the meaning of x, y. X means this distance and y means that distance. That's why this is x and that's y. And then width of this is dx. Good? Are you with me so far?
Shouldn't it be x equals -1/2?
Why is it? Oh my God. This is, of course, x is equal to -1/2. Good catch. Okay. Are we all good? Now, how do we calculate the volume of this? Well, this is, remember, this is infinitely thin. So if I have, I guess I'll use this toilet paper. If it's infinitely thin, we can make a rectangle out of it. You know what I'm saying? Okay, so I'm gonna cut this thing and split it open, which will create something looking like this. Let's say about here. Do you see it? So what we have here is, this is y. Remember, this is our rectangle. And this thickness right there is dx. So only question is, how long is this rectangle? Somebody tell me how long this rectangle is.
2 pi r.
Oh, 2 pi r, eh? Why is it 2 pi r? Because that's the circumference of the cylinder, isn't it? So this side is 2 pi, I'll just say r for now. And what is my r? R happens to be the rotational radius, which is x plus 1/2, eh? Y'all with me? Y'all with me? Okay, so this is what I call dV, and I typically write it inside here. So dV is 2 pi r times h times dx. You get it? So in our case, we'll have 2 pi and x plus 1/2 times h, which is y. Good. But what is y? So my y, of course, is my function given right here, 2x minus x squared. Now I have converted everything. You see how important this meat, main ingredient, meat preparation is? Integrand preparation is, for those of you watching this video outside of Peninsula High. Now we have to multiply this out. Oh my God, that's too much algebra. 2 pi and 3/2 x squared minus x cubed plus x, eh? Too much algebra? Ne? Can you handle this? Okay, then my v here is, okay, now the vegetable. This is where this rectangle exists, and I'm hoping that you know this thing, x-intercept is from 0 to 2, right? Looking at this function, 0 to 2, okay, if that's too much algebra, ask me about it later. So 0 to 2, and then we put this meat down, 3/2 x squared minus, I'm gonna put it in ascending order. So x plus 3/2 x squared minus x cubed dx. How about that? Good. Now we integrate. So we'll have x squared, therefore 1/2, plus x cubed, therefore divide by, so this becomes 1/2. Good. And then minus x to the 4th power. Notice I always write the exponent first, then the coefficient. Slightly faster and easier to think that way. Now the most difficult part. Multiply and add. Tell me what this thing becomes.
4 pi, I think.
Wow, amazing, right? Volume of the, I chosen it to be like that, but hey, that's amazing. Volume of this bundt cake is exactly 4 pi. And it's also amazing that high school students in Calculus BC can multiply and add, because those are rare things these days. Number 28, region bounded by, so let me sketch this region. So there's this, and then y is equal to x, of course, look like this. And then y is equal to square root x, look something like this. You know what I'm saying? I'm gonna make this thing a little longer. So this. Now, something that you have to be careful is that you do not want to make this thing so tiny, okay? Make it big, okay? Otherwise, I cannot, if you do that on the test and everything is like so tiny, I cannot read anything, okay? So now we have to revolve this about the y-axis, right? Okay. Now, so let me draw the rectangle, and I'm going to put that rectangle about here, like that. Change that to red color as always. So this thing is dx right here, and this thingy, okay, let's label this thing. Y is equal to x, and y is equal to square root x. So I'm going to call this thing y1 and this thing y2. So far so good. Let me switch the ice pack underneath this thing. It's almost melt. Okay. Now, if I revolve this thing, then it's going to look like this. Here's the inner one, and here's the outer one. So far so good. Okay. So we have this looking thing. Alrighty, we'll call this thing dv. dv is 2 pi r, rotational, whatever that circumference, 2 pi r, times dh times dx now. So 2 pi, and we have to figure out rotational radius, and that sure seems like x now, doesn't it? So 2 pi x. And h happens to be here. This is y2 minus y1. I regret putting this thing right there. Good. This is y is equal to x. So we'll put y2 minus y1 and then dx. Any questions so far? And y2, y1 happens to be 2 pi x, and y2 is square root x. Minus y1 is just x. Good. And then dx. Now we are ready to integrate. So v is from, do you see that this coordinate is 1, 1? I'm going to put it underneath. So 0 to 1, 2 pi x. I'm going to distribute this thingy. So now I have x to the 1/2, 3 over 2 power minus x squared. How about that? Okay, so 2 pi constant outside, and x to the 5 over 2. Therefore, 2/5, and minus x cubed, therefore 1/3, and from 0 to 1. Okay, luckily this is only 1, so 2/5 minus 1/3. That is 1/15, right? How about that? Good. Okay, now we'll move on to number 31. Okay, we have to find the solid revolving this region about the line y is equal to 1 and y is equal to 2. Y is equal to 1 and 2 seem like about the same thing, right? Oh, whatever. Okay, so what we have is this. Say we have this thingy, and we have a parabola. Say it looks like this. Okay, and then y is equal to 1 is about here, let's say. Okay, so this region, we have to revolve it about y is, I'll just do b. It's about the same idea. Y is equal to 1 is a lot easier. It's just from here, but y is equal to 2. So that rotational radius, let's say, is here. This is y is equal to 2. Good. Okay, I'm gonna draw the rectangle as always. So this time looks like washer method is preferred way, eh? I'm gonna move this thing up so I can finish drawing this thingy. Okay. My mouse is really not functioning today. I don't know what's wrong with this thing. This button is being weird. Okay. With that. What did I do? That's done. I wanted this thing. Like that, right? Okay. So this is the washer that I want. So far so good? Okay, let's write that down, the dimensions. So this is dx. Okay. Now we have to figure out this inner radius, r. Well, y is 2, meaning from here to here is 2, and from here to here is y, isn't it? When we say y, when we say y, that is this much. You know what I'm saying? So this thingy is just 1, isn't it? You get it? Do you get it? And then this is our outer radius. This is what I call capital R right here. Now, when I say y is that much from here to here, right? So this must be 2 minus y. Do you see that? From down here to all the way up to that line is 2, and this much is y, so what's left? We subtract from 2 by y. So my dv here is pi big R squared minus small r squared dx happens to be y, and big R squared is this one, 2 minus y squared minus small radius, which is just constant 1 squared. Who's lost? Okay. Now I'm gonna multiply this out, so I will have 4 minus 1, so I'll have 3 minus 4y my plus y squared. Too much algebra? What did I? Yeah, I don't want to. Yeah. Well, hold on. I'll back up. I'll substitute first, otherwise it'll confuse you a lot. My y happens to be here, x squared, eh? So I'm going to substitute that now. So we have 2 minus x squared, quantity squared minus 1. Good. Now I'm going to multiply this out. So I will have 4 minus 1. So we have 3 again. Minus 4x to the fourth. X squared plus x to the fourth. Y'all with me? Okay, so let's integrate it. So v is from 0 to 1 and double it. You all see this intersection is 1, 1. And then pi and 3 minus 4x squared plus x to the fourth power and dx, and that is 2 pi outside as constants, so 3x minus x cubed, therefore 4/3, plus x to the fifth, therefore 1/5, 0 to 1. Oh, most difficult part, fraction addition. But I have answer key, 56 pi over 15. How about that?